Good afternoon, everyone. My name is AZZATUL ATHIRAH. Today, I will be presenting on carbon neutral construction and discussing whether it's a realistic goal or just another trend. With the construction industry accounting for approximately 40% of global carbon emissions, this topic is increasingly important in the fight against climate change. As the demand for sustainable building rises, the question remains: can we truly achieve carbon neutral construction, or is it just a fleeting idea? In this presentation, we will explore the key aspects of carbon neutral construction, its benefits, challenges, real-world examples, and emerging trends that may pave the way for a more sustainable future in the built environment. Let's begin by discussing why carbon neutral construction is essential. The construction industry's substantial contribution to global carbon emission primarily come from energy consumption, material uses, and the emission produced during construction processes. According to the United Nations Environment Programme, the industry accounts for nearly 40% of global carbon emission, highlighting the need for substantial changes in how we design, build, and operate buildings. Carbon neutral construction aims to counter this by minimizing emissions. The goal is to make buildings as energy efficient as possible, use renewable energy sources, and reduce overall carbon output by choosing sustainable materials. In doing so, carbon neutral buildings not only reduce their environmental impact but also contribute to mitigating climate changes by lowering greenhouse gas emissions. One of the most significant benefits of carbon neutral construction is its positive environmental impact. By using energy efficient systems and renewable energy sources, carbon neutral buildings can dramatically reduce their carbon footprint. First, energy efficiency. Energy consumption can be minimized through strategies like high performance insulation, efficient heating and cooling systems, and advanced window technologies. These measures reduce the building energy demand, resulting in lower carbon emissions. Second, renewable energy. Integrating renewable energy systems such as solar panels or wind energy into buildings further reduces the needs for fossil fuels, helping to achieve energy independence for the structure. Solar panels, for example, can offset a significant portion of building energy consumption, pushing it closer to carbon neutrality. Third, sustainable materials. The use of sustainable materials like recycled steel, low-carbon concrete, and natural building materials help reduce the overall carbon emission associated with the construction process. Energy efficiency is the cornerstone of carbon neutral construction. The aim is to reduce energy consumption while maintaining comfort and functionality. Let's break down some of the key strategies. First, building envelope. The building exterior plays a vital role in energy efficiency. High-performance insulation, airtight windows, and proper sealing of doors prevent heat loss in the winter and keep building cool in summer, reducing the need of mechanical heating or cooling. Second, efficient HVAC system. Heating, ventilation, and air conditioning (HVAC) systems are significant energy consumers. However, modern efficient HVAC systems can reduce energy consumption substantially. Smart building technologies that adjust heating and cooling based on occupancy or weather conditions also contribute to energy efficiency. Third, lighting. LED lighting, which consume significantly less energy than traditional incandescent bulbs, is widely adopted in carbon neutral designs. Additionally, natural daylighting through skylights and large windows reduces the need for artificial lighting. While the benefits of carbon neutral construction are clear, there are substantial challenges to achieving this goal. First, upfront costs. Sustainable technologies, high-performance materials, and renewable energy systems come with a high initial investment. Many developers are hesitant to adopt these technologies due to the perceived costs, even though long-term saving on energy bills can offset these expenses over time. Second is technical complexity. Achieving carbon neutrality requires a high level of technical expertise, including knowledge of energy modeling, building system integration, and sustainable material selection. This complexity can lead to delays, cost overruns, and challenges in maintaining optimal performance throughout a building life cycle. Third, regulatory barriers. In many regions, building codes and regulation have not yet caught up with the need of carbon neutral construction. The absence of standardized guidelines on an incentive can make it difficult for developers to adopt new sustainable building practices. Last but not least, market readiness. The availability of sustainable materials and technologies varies by region. In some areas, the market may not yet support large-scale adoption of carbon-neutral construction due to supply chain issues or lack of access to renewable energy resources. Let's now take a look at some real-world examples of carbon-neutral construction. In this case, studies demonstrate the potential of carbon-neutral buildings while also showcasing the challenges they face. First, Solaris Dotamas Kuala Lumpur. This building is a prime example of sustainable office building. It's certified under the Green Building Index (GBI) and includes features like solar panels, rainwater harvesting system, and efficient energy management system. This system contributes to significant energy saving and reduce environmental impact. The second one is the Bullitt Center Seattle, often referred to as the greenest commercial building in the world. The Bullitt Center is a net zero energy building that generates all the energy it needs on site through solar power. It also has rainwater harvesting system and composting toilet, making it a leader in sustainability. However, such a building comes with a high cost and requires careful long-term planning. The third one is Eco Terraces Penang. This residential project in Malaysia is another example of sustainable construction. It focuses on sustainable living with energy-efficient designs, water-saving technologies, and the use of recycled materials, while it showcases the growing interest in carbon-neutral projects. It also highlights the challenge of achieving carbon neutrality in residential buildings, where affordability is a key concern. To overcome the challenges and accelerate the adoption of carbon-neutral construction, several innovations are emerging. First, Building Information Modeling (BIM). BIM is transforming the construction industry by allowing designers to simulate a building energy performance before it's built. BIM helps optimize design for carbon neutrality, ensuring energy-efficient systems are incorporated from the start. Second, circular economy. A shift towards a circular economy involves designing buildings with materials that can be reused or recycled at the end of the life cycle. By using recycled materials in construction, the environmental impact of new building is significantly reduced. Third is biophilic design. This design approach incorporates natural elements such as plants, natural light, and green spaces into buildings. Not only does biophilic design enhance the building's aesthetic appeal, but it also improves energy efficiency by enhancing the natural cooling effect of plant and improving indoor air quality. As we move toward carbon neutral construction, collaboration between developers, architects, engineers, and policymakers is crucial. Here are some key recommendations. First, policy and incentive. Government should offer incentives such as tax breaks or grants to encourage the adoption of carbon-neutral construction practices. Building codes should also be updated to support sustainable technologies. Second, research and development. Continued investment in R&D will help reduce the cost of sustainable materials and renewable energy systems. making them more accessible to developers. Third is education and training. Educating the workforce about the technical aspect of carbon neutral construction will ensure that the industry has the necessary skill and knowledge to implement these technologies effectively. In conclusion, while carbon neutral construction presents significant challenges, it holds great potential for reducing environmental impact and mitigating climate change. With continued innovation, collaboration, and investment, carbon neutral construction could become the industry standard, leading to a more sustainable future.